How will nanomedicine revive cryogenically frozen people? Imagine a future where being frozen after death could mean waking up centuries later, thanks to tiny robots repairing your body from the inside out. That's the exciting idea behind nanomedicine and cryogenics revival. Right now, freezing a person involves cooling their body to extremely low temperatures to slow down all biological activity. The hope is that future science can reverse this process and bring them back to life. But the challenge is that freezing causes damage to cells and tissues, mainly from ice crystal formation and dehydration. Scientists are working on tiny robots called nanorobots that could fix this damage at the cellular level. These nanorobots are so small they can travel through blood vessels and tissues, scanning for problems and repairing them one cell at a time. The revival process might happen in 3 main steps. First, nanorobots would gather detailed information about the frozen body, creating a high-resolution map of every cell and molecule. This is like making a detailed blueprint of the entire body. Next, powerful computers would analyze this data to identify damage, broken connections, and what needs fixing. Finally, the nanorobots would carry out the repairs, rebuilding tissues, reconnecting nerves, and restoring normal function. One fascinating aspect is that these nanorobots could be made in nanofactories, machines that build things atom by atom. This would allow 4 incredibly precise repairs, almost like a microscopic construction crew. Although this technology is still theoretical, scientists have already experimented with nanoparticles and tiny robots to revive frozen tissues. For example, researchers have revived fish embryos that were vitrified or rapidly cooled by injecting special nanoparticles and warming them with lasers. This prevents ice from damaging the cells. Similar experiments have been done with rat limbs, restoring blood flow and tissue function after freezing. While these are not yet full human revival experiments, they show that the idea is not impossible. The use of nanomedicine in cryopreservation is still in its early stages, but it opens up wild possibilities. Imagine a future where people can be frozen after death and then revived decades or even centuries later, thanks to armies of microscopic repair robots. It sounds like science fiction, but with ongoing advances, it could become a reality someday. Tiny robots crawling through frozen bodies, fixing cells, and bringing people back to life is a strange and quirky idea that pushes the limits of what we think is possible in future science.